Now, having said that, in example 1, we have this question. The data below gives the number of letters received by a household each week. So you have 6, 7, 6, 7, 8, 9, etc. And of course, you won't be able to see the data towards the end. But that's how it is. Okay? So now, they will ask you, use a tally and frequency table to organize this data. When you're given a discrete data, and they will give you 6, 7, in this case, the number of letters, each of this value here will represent the number of letters that you have gotten hold. Okay? And what you need to do for this, if we are going to do for part A, you're going to draw a frequency table. Okay? Let's have a look at what numbers we can find. Okay? The highest that we have so far will be 9. The lowest we have so far would be 1. Okay? So we need to draw a table, right, with the number of letters ranging from 1 to 9. So we'll just have this. Okay, number of letters. Oops. Number of letters. And also frequency. Alright. Draw the table. Make sure that it's drawn properly. Okay. The number of letters we have so far will start from 1. What is the frequency? Frequency here means how many times do you see the number 1 in the data above? How many? Just 1. Okay. If we see 2, 3, 4, 5, actually 5 is given here. So if we have 2, 3, and 4, do we see any 2, 3, and 4 numbers on the data? No. So which means, in other words, 2, 3, and 4, not to worry about it. Okay, we'll just leave it as 0, 0, and also 0. Right? Now we will go on to number 5. Okay, and we have to count, and this is what it means by discrete data. You are actually using each of this number to actually count the frequency of the letters that have been received by the household. Alright, so number 5 here, we'll go back. We have 1, we have also 2, so we have only 2 so far. Okay, next we'll move on to 6. So count 1, 2, 3, 4, 5, 6, and 7. So you have 7. You have 7 in total of 6 letters being distributed to the household. And we'll move on, of course, to 7, 8, and also 9. Okay. Now let's count again. 7. 1, 2, 3, 4, 5, 6, and 7. So 7 would also be 7 in terms of its frequency. Okay. Next, we come with 8. 1, 2, 3, 4. Alright, so we have 4. And of course, the remaining 9 will count. 1, 2, 3, 4, 5, and 6. Now, having a look at this. Okay, having a look at this. Which one do you think is the most frequent number of letters that each household will get? 6 and 7. So this is how you do. You're actually tabulating each data and you're actually sorting out into the particular and also number of letters that you have allocated. Okay, that's how you draw the tallying. And if we want to know the total number of that letters they have received, we do not add up the number of letters, we just have to add up the frequency. We just have to see how many times that these letters are being distributed, because each of these letters are actually given to each household, like how much do they receive in a week itself. Okay, it can be in the morning and afternoon, and we tabulate it from there. So all we need to do here is to total up the amount. Alright, so 1 and 2 will give you 3, 3, 7 is 10, 10, 7 is 17, 17, 4 is 21, 21 and 6 is 27. So you have 27 in total that have been distributed, alright, to each household. Okay, that's how you do it. Now, how do we display the data using a column graph? What we need to do, Do you see the number of lattice and frequency we have here? Once you have tabulated the data, once you have written the data down, all you need to do is to think of a column graph. And we will always draw this using a vertical column graph. Okay, so this will be the number of lattice, and this would be the frequency. Alright, the y-axis here would be your frequency, x-axis would be your number of lattice. And again, we'll go down to maybe 1, 2, 3, 4, 5, 6, 7, 8, and also 9. Okay, so having said that, we have to look at the axis for your y-axis, and we have to determine the scale. Alright? Alright? So we know that the highest number here is 7 and the lowest is 1. So we think of it like, okay, we still have a chance to give it a space. So we'll just put it this way, we'll use 10 units. Alright? So again, 1, 2, 3, 4, 5, 6, 7, and also 8. And in this case here, of course, 7 is the highest, so we'll just give one more number, which is 8. And that is for frequency, not to be mixed up with the number of lattice. Okay? Very different, because we're actually counting the actual number of lattice that have actually arrived. Okay? Please also make sure, I repeat, please also make sure in your book you have the boxes. I don't have the boxes here. Okay? So now, 1, the number of lattice, which is 1, you only have a frequency of 1, so we'll just draw this. Alright, this is a column graph or a bar graph here. Okay, 2, 3, and 4 is empty, so we leave it as it is. How much is 5? 2. Thank you. So we just draw it a little bit higher. How much is 6? 7. Thank you. So we draw 7 over here. How much is 7? 7 as well. Okay, that's how we draw it. How much is 8? 4. So 4 should be here. Yep. How much is 9? 6. So as you can see, alright, as you can see here, this is the column graph that we have drawn. Okay, so this is how you need to draw if they ask you to draw. Okay, now, does anyone here know what's an outlier? Anyone here? No. An outlier is actually a value which is very far off from the normal counted values. Alright? It's way too big. It can be way too small as well. Do we have an outlier in this case here? Are you sure? We have 1. This is the outlier. Alright? Because it's way off from the scale. 5, 6, 7, 8, 9, not too bad, because we'll be able to see how many has been taken into consideration. But the outlier here is just basically out from that range. So this is our outlier. One thing you have to note about the outliers. Some outliers can be taken into consideration to be analyzed. Some, forget about them. Okay, and this will be very, very obvious when you do your science courses, chemistry, physics, and also biology. When you do some practicals, you'll be able to see and identify outliers. Some can be analyzed, some can't be analyzed, but it is good to take note of the outlier, because it might be a contributing factor to your statistics. It might affect your calculations, so you need to take that into consideration. So yes, there is an outlier. And the outlier here is 1. Okay. Now, part D. Let us try to comment on the distribution of the data. Okay. So as I've taught you before, we'll just have to sort of like roughly estimate, right, from an outlier going up here, going up. What do you think, guys? Is this symmetrical or really not symmetrical? It's really not symmetrical. So it is not symmetrical. That's what you have noticed. What do you think? Do you think it is positively skewed or negatively skewed? How do you think it is? There's one which is one with 2, but looking at what we have so far, it is more skewed towards, it's more negatively skewed, it's more skewed towards the left hand side. Okay, it could be, but you've made a good point there because you have 2 bumps at the end here. So you can also comment it's not symmetrical, there are actually 2 humps given to you. I mean, it's how you comment about a data, because you can comment about anything in this case. So it's not symmetrical, it is negatively skewed. Okay, and if you want to add an addition about the 2 little humps at the back, you may do so, because it's all about commenting. You're talking about the distribution. Okay, is everyone alright with this one? Okay.